Four charges equal to minus q are placed at the four corners of a square, and a charge small q is at its center. Let us first of all see what it is trying to say. This is basically a square, and let it be A, B, C and D, right? Each of them are having a charge minus q at its corner, minus q and minus q, right? Now at the center a small charge q is placed, right? If the system is in equilibrium, what will be the value of q, right? If we see from this the net electric field or the net force on this small q charge, it will be zero. It will be zero independent of the value of q, because the electric field due to minus q will cancel out the opposite, the charge electric field due to the charge on B, which is directly opposite, and electric field due to charge on C will cancel out the electric field due to charge on A. So if we have to see the equilibrium, what we have to do, we have to see the net electric field or the net force on any one of the charges on the corner of the square, right? For example, A, if we see the net electric field on A, that should be zero for it to remain in equilibrium, right? So let us see what kind of electric field will it generate. Due to minus q charge, electric field will be in this direction. Due to D, it will be in this direction. Due to minus q, it will be in this direction, and due to small q, it will also be in this direction, right? So let us see the electric field on A. If this point is A, electric field will be due to B, right? In this direction it will be due to D, and in this direction at an angle of 45 degree from the x-axis, it will be due to C plus due to small q, right? Now what will be the electric field due to B? Electric field due to B will be equal to what? K into q upon A square, right? If A is the the side of the square, then that will be it. We are here also seeing only the magnitude because we have already considered the direction, which is correct, right? So what will be D? D will be the same, kq upon A square. What will be due to C? Now AC distance is root 2a, because in a square it will be root 2a. So basically EC will be equal to kq upon root 2a whole square. So this will be equal to kq upon 2a square, right? And what will be small q? E into small q, that will be equal to kq upon root 2a by 2 whole square. This will be small q, sorry. So this will be basically 2k small q upon a square, right? Now let us see, because electric field is a vector quantity, so we have to resolve it in the directions, right? So basically let us resolve EB in two directions, along the diagonal and one along this direction, right? 45 degree, and ED has to be also resolved along this diagonal and along this direction. The direction, let us mark this as let us suppose this is M and N, right? MAN. Now electric field along MN will get cancelled out because of ED will cancel out the component of electric field of EB, right? So we just have to see the electric field due to along the diagonal. And one minute, I just told you something. This will be EC minus EQ. It will not be EC plus EQ, because Q has to be positive, because due to Q the electric field will be in this direction, right? So that means EB cos 45 plus ED sin 45, which is basically along the component, these are the components along the diagonal, plus EC should be equal to EQ, right? Because all these are in this direction. It's only the electric field due to EQ which will be in this direction, right? It implies that cos 45 is 1 upon root 2. That means kq upon a square we can take common, this will be 1 upon root 2 plus 1 upon root 2 because ED is also same, and what is EC plus 1 upon 2, right? So this will be equal to EQ, that means 2KQ upon A square, right? So we can cancel out K and A square from both of these directions. So it implies 2 small q will be equal to capital Q to 1 upon 2 plus 2 upon root 2, right? So that means Q will be equal to Q by 2 1 upon 2 plus root 2, right? So let us see the options. It is basically in Q by 2 forms. This is not the correct, so we can just simplify it. We can take Q common, 2 common, so this will be 1 plus 2 root 2. So that means option B is correct, right?